We are now going to take a look at bouncy balls or super balls. Okay, so sequences and series depending if you're adding or finding terms. So a rubber ball is dropped from a height of 60 feet and then it rebounds 2/3 the distance. So the more super it is, then the higher up it'll bounce. So the best way to do these is to draw a quick picture. Okay, people will usually know how to do this problem, and they usually find the wrong thing because they don't have a picture to help them. So I'm going to say that the bouncy ball starts here, and that the height is 60 feet. And the ball hits the ground, bounces back up. Hits the ground, bounces back up. Now, it may not be bouncing away from you. It may just be going straight up and down, but I need to stretch this out to draw some things. Okay, so this is the ball bouncing back up. So at first, it's 60 feet, but the next height is 2/3 of that. So 2/3 of 60, 2/3 of 60 is 40. So the next height is 40 feet. And 2/3 of 40 is 80/3. I'm going to leave it exact so I don't chop anything off. 80/3. Okay, so that's kind of enough here to notice what's going on. Is this problem arithmetic or geometric? Definitely geometric. And the R value that you keep multiplying by every time is 2/3. Okay. Find the total distance the ball travels. So the ball bounces down, comes back up, bounces down, comes back up. The question is when it gets really, really tiny, what's half of tiny, or what's 2/3 of tiny? Even tinier. What's 2/3 of tinier? Even tinier. 2/3 of number is never going to make a 0. So the idea here is not finite, but infinite. The ball is going to keep bouncing and bouncing and bouncing and bouncing. Now, I know gravity usually takes over and is going to hold that ball down to the ground, but mathematically speaking, the idea is infinite. Okay, so to do part A, we are going to find the total distance. Are we going to find one height or all the heights? So part A is going to be the sum. A1, so the first height is 60. A2, the second height's 40. A3, so A1 over 1 minus R. A1 is 60. 1 minus 2/3 is the R. And 60 divided by 1/3 is 180 feet. Okay, so what did we just do here? We just added up all the heights. We added up this height, and this height, and this height, and this height. Wait a minute. What about the ball bouncing back up? We just added all the downs. So here comes the fun part. We're always going to multiply this by 2. The reason that you multiply by 2 is for the ups. Okay, so 180 times by 2 is 360 feet. So I'm going to multiply all these by, so I'm going to get this up. See, get this up. There's 2 80/3 and there's 2 40s. Oh, wait a minute. This one doesn't have an up. So the first step is you multiply by 2. But then we have to subtract off 60. Okay, and the reason is the first one, there's no up. So the final answer here is 300 feet. Now I'm not going to call that S because S is that number. I'm just going to label this as total distance. Total distance. That would be the best labeling for that one. Okay, let's go take a look at part B. Find the height the ball will bounce up to after it strikes the ground for the 8th time. Okay, the best way to do this is to examine your picture. Here's the ball striking the ground for the first time. Boom, bounces back up. Here's the ball hitting the ground the second time, bounces back up. Here it's hitting for the third time. It's going to go up to A sub 4. Yada, yada, yada. After it strikes the ground for the 8th time, it's going to go up to A sub 9. 1 bounces up to A sub 2. The second bounce 3. 3 goes to 4. 8's going to go to 9. So question B says find the height. That's not total distance. That's just the height. They're asking you to calculate A sub 9. Okay, A sub 9. That's a term. A geometric term is A1, 60, times R, which is 2/3 to the power of 8. Okay, please calculate that. And the height is 2.34 feet. Okay, so that was asking you to find a term or a height. Okay, what is part C asking us to think about here? Find the distance traveled by the ball when it hits the ground for the 6th time and then stops. So when it hits the ground for the 6th time, here's the 4th time, then the 5th time, then the 6th time. Okay, here's A sub 5, here's A sub 6. So I think what I'm going to do is I'm going to add A1, A2, A3, A4, A5, A6. Okay, find the total distance traveled. So is this finite or is this infinite? This is going to be finite. I'm going to add up, I'm going to sum how many terms? S sub 6. Okay, the formula is A1, 60. 1 minus 2/3, the R value, to the power of n, which is 6. I don't really need to put that in parentheses, but you can, over 1 minus 2/3. Okay, so S sub 6, the sum of those 6 heights is, rounded to 2 places, 164.20 feet. Okay, so that wait a minute, that's the sum of 6. That's the sum of 6 heights. Remember what we have to do when we're adding up the total distance? The first thing is we have to multiply by 2. Do you know why? Because of the ups. Okay, let's multiply by 2. So I guess the answer is 328.40 feet. Wait, that's not the answer. What's the second thing you always have to do? We have to subtract 60. Subtract 60. And that's because of the first height. Okay, so the distance is 268.40 feet. Okay, 2 important things. Times by 2 for the ups and subtract the first one. Okay, here's the bouncy ball ideas and notes. Okay, so when you're doing bouncy balls, there's a couple of things we have to remember. Okay, bouncy ball or super ball, bouncy or super ball, whatever you want to call these, problems are geometric. They're geometric because you multiply, multiply, multiply. Okay? What's the second thing we have to remember? Okay, in theory. So the theory behind these is bouncy ball problems. Bouncy balls are infinite, geometric, convergent. Did you ever see that thing where somebody stands here and they say, okay, I'm going to walk Here's the door. I don't know why it's leaning over. I'm going to walk halfway to the door and they get here. And then I'm going to walk halfway to the door and they get here. I'm going to walk halfway to the door, halfway to the door, halfway to the door. And I say, well, what are you actually going to get to the door? And half of tiny is even tinier. So in theory, you never get to walk through the door. Okay, so that's the theory. That's why to find total distance, what you're always going to do is calculate an S. Okay, but if it says distance after X bounces, okay, then they don't want it to bounce forever. After X bounces, then the idea is S sub n. Then it would do a finite one. Okay, and remember, for both of these, the idea is you times by 2 because of the ups, and then you always subtract off A1 because the first one has no up. So that's the idea with bouncy balls. There's some guidance for you. Let's take a look at another one. A bouncy ball is dropped from 15 meters above the ground. So let's just get the ground and kind of get the ball going here. So it's dropped from 15 meters. Okay. Then it bounces up to the second height and the third height. So the first height is 15. The second height is going to be a little less. It bounces up to 60% of its previous height. So if you have 15 times 0.6, I'll put this calculator over here. 15 times 0.6 is 9. So A sub 2 is 9 meters. And 9 times 0.6 is 5.4 meters. Okay, just enough to kind of get the idea. What is the total distance the ball travels when it hits the ground for the 10th time? Now remember, most people are going to do this problem and they're going to know what to do on the test, but they're going to be one number off. Okay, so let's just really think about hitting the ground for the 10th time. So here are some bounces initially. Here's the ball hitting the ground for the first time, the second time, the third time. Here's the fourth time, yada, 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 when it hits the ground for the 10th time. The question is, what term is this? I need to know this height. A sub 3, then hits the ground, bounce 3. A sub 4 hits the ground, A sub 4. So this must be A sub 10. So I need to find the total distance when it hits the ground for the 10th time. So it's not a term, it's not a height. This is going to be a sum. Is it going to be finite or infinite? Okay, this is going to be finite. This is going to be an S sub n problem. And we're going to sum how many? 10. We're going to add up A1, A2, A3, A4, all the way to A sub 10. Geometric sum formula starts with A sub 1, which is 15. 1 minus r, which is 0.6 to the n power. That's a 10. Then divide by 1 minus 0.6. So the sum of those 10. And the sum of those 10 terms is approximately 37.27 meters. Okay, is that going to be the answer? No, because remember, the first thing you always have to do is times by 2. Timesing by 2 gives us 74.54. And then, that's not the answer either. What we're going to do here is subtract. Subtract the first one, subtract 15. And that's going to give us 59.54 meters. Okay, don't call that S sub 10. S sub 10 is there. This is the distance. I'll label it distance. Okay. All right, here's something we're going to use in a couple days. Binomial coefficients, the binomial theorem uses this calculation. Okay, and what this says is n things, I'm going to choose R of them. So I have n things, maybe I have n students, and I'm going to choose R of you to go help me carry some big heavy boxes. Here's how you would write it. N, choose R. The C is really big. Okay, and here's the formula. So in the numerator, it's n factorial, and then divide by R factorial, and then the difference factorial. Now, which number is always going to be the bigger number? The n number or the R number? The n one's always going to be bigger, or I guess it could be equal. So it's always going to be n minus R. Okay, and remember, factorial is not exciting. 3 factorial, this is a mathematical calculation here, means 3 times 2 times 1, all the way down. Okay, all right, so let's compute these without a calculator, meaning you have to show me this formula. If you don't know 9 times 5, then go ahead and type it in your calculator, but don't tell me, okay? Without means show the formula. Okay, show the formula. So if we have 6, choose 4. 6 students, I'm going to choose 4 of you and give you a candy bar. Yay! How many different ways can I pick the 6 students? So in the numerator, it's 6 factorial. The bottom number goes in the bottom, 4 factorial. But then down here, you also need to subtract them. 6 minus 4. So what we need to do in the numerator is 6 times 5 times 4 times 3 times 2 times 1. Now, how about 4 factorial? 4 times 3 times 2 times 1. And 2 factorial is 2 times 1. Now, please do not start multiplying all this, okay? Multiplying goes along with canceling. So I'm going to cancel a 4 and a 3 and a 2 and a 1 with a 4 and a 3 and a 2 and a 1. 1 really does nothing. I've got a 2. Let's cancel 2 with 6, which is 3. So the only numbers I have left are 3 times 5, so the answer is 15. Okay, let's try it again. Let's do 11, choose 3. In the numerator, you put 11 factorial. Down here, you put 3 factorial, and then the difference is 8 factorial. So let me show you how you could start writing this a little easier. 11 factorial is 11 times 10 times 9 times 8 factorial. I just wrote 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 by writing 8 factorial. You know why I did that? You can see coming up here. 3 times 2 times 1 times 8 factorial. So what I'm going to do is cancel 8 and 7 and 6s and 5s and 4s and 3s by canceling those 2 factorials like that. I'm also going to cancel 3 and a 9 to make a 3. I'll cancel 2 and 10 to make a 5. And so 11 times 5, 55 times 3 is 165. Okay, 7 factorial. Or 7, choose 0. There's 7 factorial, 0 factorial, and 7 factorial. Now I can tell right away that the 7s are going to cancel. And so I've got 1 over 0 factorial. The question is, what is 0 factorial? And if you don't know, you could always ask your calculator to remind you. Okay, so let me show you where your factorial button is. 0 factorial. So we're going to hit math, and we're going to go all the way over here to the probability column. And number 4's factorial. 0 factorial is a 1. So 1 divided by 1 is 1. The answer is 1. Really? There's 7 students. 1, 2, 3, 4, 5, 6, 7. I put some girls in there. There's 7 students. Okay. I'm going to choose 0 students. I'm going to give somebody a prize. Out of 7 students, I'm going to pick 0 of them. Ready? I pick this person. Wait. No, hang on. I was supposed to choose no one. Okay, I'm going to pick her. Wait a minute. Hang on. 7 students. You're only supposed to pick no one. Okay, done. There's only one way for me to pick no one, and that's for me to pick no one. There's only one way I could possibly do that. So 0 factorial is a 1, something for you to remember. Okay, I am going to ask you to show me this formula on the test. After you show it to me once, then you can just type things in your calculator by hand. Okay, but I need to see setups. Otherwise, we would just type 7. We go back to the probability command, which is number 3. 7 is going to go into the end spot. I'm going to choose 0, and the calculator can do these for you. So I am going to ask that you show me the setup tonight and do the calculations, and then after you prove to me you learned it, then we'll just use our calculators. Great. See you tomorrow.